Continuing on our work with polynomial operations, we're taking a look at polynomial multiplication today. I like multiplication the best out of all of them. We are going to need to keep in mind our exponent rule for multiplication today, which is to add your exponents and multiply those coefficients. So there are actually 4 types. I'm sure you're really excited to hear that. And this is also going to need those terms that we looked at in the polynomial addition and subtraction video. So if you haven't checked those out, make sure that you do that today. So anyways, type 1 is going to be a monomial times a binomial. Now, if you think back to a monomial that had 1 term, a binomial is supposed to have 2 terms. So if you think through this for a second, if you're multiplying one thing by 2 things, we should end up with 2 things. 1 times 2 is 2. And what we're going to think for this section is the distributive property. So to recap the distributive property, that's where you take whatever's on the outside of the parentheses and multiply it by each term on the inside of your parentheses. So I'm going to end up doing 4 times 5x, which would leave me with 20x, and 4 times negative 7, which would make negative 28. Now I don't have any like terms to combine, so that makes this my final answer. And surprise, congratulations, you just took a monomial times a binomial. So a lot of this you already know how to do. Now, the difference is we're going to start distributing variables. This is where your exponent rule for multiplication is going to start coming into play. So do remember that you have exponents of 1 here and here. So as I distribute, 3x times 9x is going to make 27x squared. So remember, I'm taking 3 times 9 to get 27 and 1 plus 1 to get 2. When I multiply this direction, 3 times negative 7 will make 21. And this x kind of rides this wave and plops itself back there behind the 21. It's almost like saying 1x plus no x does still leave you with 1x. Again, no like terms, so this makes our final answer. It can get a little funky if you're trying to work with negatives or exponents other than 1, so just be careful. Negative 4 times 6 makes negative 24. And 2 plus 3 makes 5 as your exponent on the first term. Negative 4 times negative 2y squared is going to be a positive 8y to the 4th. So just be careful of your signs. Again, no like terms, so that's that. We can also do multiple variables at one time. If it helps to fill in the little ones just to make sure that you don't forget them, please do. So we have 3 times 6 on the first term, which will be 18. We have a 1 plus a 4, which will make a 5 as the exponent on the x, and 3 plus 1, which will make 4. All right, moving on to the next term. 3xy to the third times 5x to the third. 3 times 5 will be 15. X and x to the third will make x to the 4th. And although this term didn't originally have a y, this term did. So now that will be a part of this term also. And that again makes my final answer. For these two to be like terms, all of the variables and all the exponents would have to match. They do both have x's and y's, but those exponents don't match on those terms. All right, moving on to the next type, we're looking at a monomial times a trinomial. So we're taking one thing times 3 things this time. So we should end up with 3 terms in our answer. Kind of like we did up here. We were taking one thing times 2 things and getting 2 things in our final answer. We still want to think the distributive property, so this really isn't all that different. We're going to take 4y times 3x squared. Now do remember that piece of the exponent rule that says I can still multiply the 4 and the 3 even though these have different letters, but I can't combine these exponents. I'm not allowed to take this 1 plus this 2 because you have different bases. So instead I can keep the x squared and the y separate and just write them together. Moving on to the next term, we'll have 4y times 8y squared. 4 times 8 will make 32. And now I can combine my exponents because I have the same variable. 1 plus 2 will make 3. And I have this guy all the way out here now. 4 times negative 12 will make negative 48. And that y will just plop itself back behind there on that last term. Again, no like terms to combine. That fun part comes later. But for now, that's our final answer. Again, you can see lots of different things going on, lots of exponents. Remember those implied ones? We have a few of them here. We have a couple on the exponents and also one here as a coefficient in front of that last term. So just be careful what you combine. So if I multiply the first terms, 3 times 2 will make 6. A squared and A will make a to the third. B to the third and b to the fourth will make b to the seventh. Moving on to the next term, 3 and -3 will make -9. A squared and a cubed will make a to the fifth. B cubed and b to the fifth will make b to the eighth. We have one more branch to this wave here. 3 times 1 will be 3. A squared and a will make a to the third. And b cubed and b will make b to the fourth. No like terms. So that's my final answer. All right, so nothing too new yet. Now on the next section, this is probably the first truly new piece that you're gonna have. So this will be a binomial times a binomial. So we'll be taking 2 terms times 2 terms, and you'll see that we end up with 4 terms as part of our multiplication process. We're still applying the distributive property, but it's going to end up happening 2 times. And this is a special kind of polynomial multiplication, and it has its own name. It's actually called FOIL. Yeah, just like what you wrap your leftovers in. So FOIL is an acronym. And it just helps you know what order to multiply your terms in so you stay organized and make sure that you don't miss anything. So F stands for first. So we're going to be looking at 2 chunks times 2 chunks. And the first terms are the ones that are the first in each set of parentheses. O stands for outside terms. These are going to be the 2 that are farthest apart in your problem. So as you can kind of see, we've taken the first term and given it to both the first and the second terms in that set of parentheses. So basically, we've distributed the first thing. The I stands for inside, which you probably could have guessed since that one was outside. So these would be the 2 that are closest together. And I'm sure if you're a great guesser, if F was first, L is going to end up being last. All right, these would be the ones in the back of each set of parentheses. So in this, you can kind of see we've taken that second term and given it to both the first and second terms, aka distributing it. So we're going to end up distributing the first term and then distributing the second term. All right, so let's take a look here. I'm going to try to color coordinate this a little bit just so you can see what term is coming from which piece. I know that some people like to draw all their lines at one time, but really drawing the lines, those little arcs that we've been putting on our problems, is to help you make sure that you've hit each term as you go. I still see people draw all the lines at the beginning and still skip terms. So do draw them one at a time. All right, here we have x times x. Okay, remember there are 1's in front and exponents of 1's. X times x is going to end up making x squared. That's our first terms. Okay, next is going to be x times 5, which should give you 5x. Okay, these were our outside terms. So we've done faux so far. All right, after that, we're going to distribute the second term. So I basically distributed the x. Now that everybody has an x, we're going to distribute a 3 and make sure everybody gets a 3 as well. You get a 3 and you get a 3, kind of like Oprah. So we have 3 times x, which is 3x. That was our inside term. And finally, we have 3 times 5 out here on the back. These are going to be our last terms, and that makes 15. So we took 2 things times 2 things. So 1, 2 terms times 1, 2 terms, and got 1, 2, 3, 4 terms. Now you may notice something is that here in the middle, we actually have like terms. So these problems generally have 2 steps. I do need to combine those like terms in the middle to create a final answer. So the x squared shouldn't have anybody to combine with it. Same thing with the 15. Your like terms, if you've done this process correctly, should be sandwiched here in the middle. Those 2 things should combine. Now, if at any point you find that this term can combine, or these 2 can't combine with each other, you may want to double check your work. Check for things like dropping x's, leaving off an exponent where there should have been an exponent. Things like that are the common errors that tend to happen. All right, here I'm going to do 5x plus 3x, which should make 8x. And that plus 15, like we were talking about, should be the other piece that just drops on down. So this part stayed a part of my problem, this part stayed a part of my problem, and these 2 combined to create 8x. That makes this my final answer. All right, let's take a look at that one more time. well, actually a few more times, sorry. So we have 2x times x, which should make 2x squared. 2x times 4 should be 8x. Negative 3 times x will make negative 3x. You do want to include that negative as you distribute this 3. And negative 3 times 4 should make negative 12. All right, again, those like terms should be sandwiched there in the middle. So my final answer turns into 2x squared plus 5x minus 12. Now, when we do these in school, this is one of my favorite set of notes to do because I can turn these little arcs into so many different things. And we talk about, hey, what does this look like? Or what could we turn this into? And it's just another way to help you remember that you're doing this correctly and you've got all your lines and you've multiplied all your pieces. So this is the most traditional thing that I end up turning this into. And it happens to be, you can kind of see if you can make it out. You can turn it into a crab with one giant claw. So far, he looks a little too friendly, so I'm going to give him some angry eyebrows. There we go. We don't like math anyway, right, you guys? Okay, so if I keep going, all right, let's move on to the next example. We have lots of negatives to deal with here. So as I go, here's what we got. So we're going to do 3x times negative 6x. That'll be negative 18x squared. All right, we also have 3x times negative 9. So make sure that you write that out as a negative 27x. All right, be careful to distribute this as a negative 1. So negative 1 times negative 6x is going to make a positive 6x. And negative 1 times negative 9 will make a positive 9. Again, those like terms should be sandwiched here in the middle. So I'll have negative 18x squared minus, let's see here, 21x, negative 27 plus 6 will make negative 21, and plus 9 will just come on down for the ride. All right. We do have some weird things that can happen with these, and these do have the most examples out of all the types that we have, just because these tend to be the most popular. They're going to come up in full force when we get to a section called factoring, and also solving quadratics by factoring as well. So these ones are crucial to understand. All right, so these next ones here do have double variables, which you don't really see all that often. Most of what you're going to see is going to look like these, with an x term in the front, numbers in the back, and you'll be good to go. All right, so we're still following that same process. Just watch those variables. Be careful about what you have and what you can combine here. So I'm going to look at 3x times negative 4x. That'll give me negative 12x squared. Okay, I'm also going to take 3x times 5y. So that'll give me a positive 15xy. Remember, I can't combine those exponents. I just have to write the variables together. All right, for my next term, I'm distributing 2y. 2y times negative 4x will make negative 8xy. And 2y times 5y will make 10y squared. Those ones I am allowed to combine because they are both y's. Okay, now even though I have two variables, I should still have like terms here in the middle. Now you'll notice that this one went xy and this one went yx. The commutative property says that I can flip those around and still make them look the same. So that way it's just easier for me to recognize that they are indeed like terms. They have the same variables with the same exponents, so they still can be combined. The first term and last term still drop, and my middle term combines, in this case, to make 7xy. All right, another couple of special ones. This one just acts a little bit weird, and this one will come up again during factoring. Just kind of fun. Let's see what color do we want on this one. We'll just stick with purple and blue, I think, for right now. All right, so we have x times x, which is x squared. That's not really a big deal. Then I have x times -5, which will make -5x. You may already see what's about to happen as I multiply the next things. 5 times x will make positive 5x, and 5 times -5 will make -25. All right, the only weird thing here is when I go to combine like terms, 5x and -5x end up canceling each other out. So remember, I don't put anything as part of that term. So all I have left in my problem is x squared and that -25 from the back. So that middle term ends up going missing. All right, the last weird thing that can happen is they can actually write your problem like this. And what it requires of you is to remember what that exponent is telling you. So it's not saying square x and square 3 and be done, kind of like your power to power rule. The power to power rule does not work over addition and subtraction. What we have to remember is that that squared is telling you that this thing is happening 2 times. So the problem that I'm actually trying to do is x plus 3 times x plus 3. So I still need to use FOIL to make this happen. X times x will make x squared. X times 3 will make 3x. 3 times x also makes 3x. And 3 times 3 will make 9. All right, I do have to make sure that I combine like the terms in the middle. Had I just squared the first thing and the last thing, I totally would have skipped over this middle piece. I would have just had x squared plus 9 and would have walked away from it. But this actually makes my final answer. All right, we do still have one more type to take a look at. It is a little bigger than this, and it's the last one that you're required to know. So if you take a look, this is going to be a binomial, so again, 2 things, times a trinomial, so times 3 things. 2 things times 3 things is going to end up making 6 terms in our problem, which is crazy. Now, you still want to think the distributive property, but not quite FOIL on this one. FOIL only works whenever there's 2 by 2s. Here we're going to have 2 by 3. So if I try to do FOIL, I end up skipping over this middle term completely, which is no good. We don't want to do that. So what we do is we think of it more like the distributive property twice. I want to make sure that all of these things get the x, and then that all of these things get that 2, and then we're going to combine some like terms. All right, so we're going to start here with x times 3x squared. So I should end up with 3x to the 3rd on this one. So you'll notice that our exponent is a little bigger here. All right, next I'm going to have x times 4x, which will make 4x squared. And x times 5, which will make 5x. So I've distributed that x to everything at this point. Right, then I have to switch over and distribute the 2. So I'm going to draw those lines underneath just to make it easier to read. So 2 times 3x squared is going to make 6x squared. 2 times 4x is going to make 8x. These things are positive, so that's where all these plus signs are coming from. And 2 times 5 out here in the back is going to make 10. All right, I call these rainbow problems because when I use a bunch of different colors, they get kind of rainbowy, which is kind of fun. Now, like term-wise, similar to the binomial-binomial problems, the first thing and the last thing should not combine with anything. If you get something else with an x to the 3rd, or have an extra x squared here, or have something that's going to combine with the 10 because there's no x on it, something probably happened that wasn't quite right. You may have dropped an exponent, dropped an x, thrown an x somewhere it shouldn't be, put an exponent on something that shouldn't have one. Just check for those kinds of things. So the first thing and the last thing are going to be part of our actual final answer. Now, what else you'll see that's different here is you're going to see 2 sets of like terms. So I see a 4x squared and a 6x squared that will go together, and a 5x and an 8x that will go together. They should alternate like that, and there should be 2 sets just like that. Okay, so the 3x to the 3rd is going to come straight down. I'm going to combine my x squareds. 4x squared and 6x squared make 10x squared. 5x plus 8x will make 13x. And that 10 from the back will also come straight down. And that should make my final answer. If you go in order and follow straight along and everything's already in standard form, it will also put your answer in standard form for you as well. All right, we have one more example, then something else to think about, and then a couple problems for you to try out coming your way. All right, so we have 2x and x squared, which should make 2x cubed, or 2x to the third power. 2x times 4x to make 8x. 2x times negative 11, which will make negative 22x. Okay, be careful of those signs, and that's going to become really important as we move down here to the next one. We're distributing a negative 1. So I have negative 1x squared. If you don't want to write the 1 part, you don't have to, but you do need the negative. Negative 1 times 4x will make negative 4x. And negative 1 times negative 11 will make positive 11. All right, my like terms should be in similar places here. We have 8x. Ooh, I dropped my squared on that one. Good thing I saw that. I could tell it wasn't quite right because it wasn't combining with this one. All right, and this term here and this term here should go together, negative 22x and negative 4x. See how easy it is to make those mistakes? So we have 2x cubed. We have these two that'll combine. 8x squared minus 1x squared will make 7x squared. Negative 26x. And positive 11. Now, something else to think about is how would a trinomial times a trinomial work? Now, think about the number of terms that you would have. You'd have 3 terms from this and 3 terms from this, which would ultimately lead you to have 9 terms. Now, your process will end up being the same. We would still end up distributing each piece to that second trinomial and then having like terms to combine. So we're not going to do this the whole way, but think about how that would work. And this, let's say, apply to any kind of polynomial. So although all you have to know here for Algebra 1 is binomial times trinomial, here's how it would work beyond that. I would have to distribute the first thing. We would distribute that second thing. So that would ultimately make 6 terms there. And then we'd have to distribute this negative 4 to get the remaining 3 terms. All right, now's a great time to pause the video and try out these 2 problems here at the bottom. You have a monomial times a trinomial and a binomial times a binomial. All right, if you've done your problems and are ready to keep rolling, here should be your final answers. On this one, you should end up with 15x to the 7th plus 10x to the 5th minus 30x to the 3rd. On your second problem, after combining like terms, your final answer should be 4x squared plus 7x minus 15.